Good morning, everyone. How are you? I hope guess fine. So today we'll start chain serving. Okay, let's start it. So what is chain serving? Chain serving is the type of serving in which only linear distance is taken on a field. The type of service is suitable for surveys of small extent on open ground to secure data for exact description of the boundaries of a piece of land. So it is only taken in a small piece of land. Yeah. The principle of chain survey or chain triangulation, as it's sometimes called, is to provide a skeletal framework of a number of connected triangles. As triangles is the only symbol figure that can be plotted from the length of the sides measured from the field. So you can see here in the figure that the measurement of the area made is made by number of interconnected triangles. So it is based on triangulation, chain triangulation. So types of chain includes metric chains can come in lengths of 5 meters, 10 meters, 20 meters and 30 meters. The Bureau of Indian Standards, BIS it's known, has published a code IS 1492 is to 1954 which provides the standards for the metric chain. The metric chain consists of a 4 millimeter diameter galvanized mild steel wire bent into rings at its ends. Two such links are connected by three circular or oval rings to provide flexibility in handling. The links, except the end links, are 200 mm long between the central rings at the ends, and the end links are shorter in length due to provision of handles. The handle has a groove at its outer end to facilitate holding arrows and fixing them to the ground at the end or the beginning of the chain. To facilitate reading the fractions of a meter, appropriate markings are provided depending on the length of the chain. So here we can see in this figure that these are the interconnected chains which are about 200 millimeter long, and these are the end links, yeah, that's what they are called, links. So links, these are the end links, and they are given they are extended to so that we can that we can carry them. This is the handle, this thing. Okay, then let's go to tapes. Okay, tapes, yeah. Tapes are made of many materials and have the advantage of being lightweight and can be used to provide great precision. They cannot stand very rough handling as can chains, yeah. They can be divided into three classes. Here, so I did something wrong. Sorry, pardon. Three classes. I'm sorry. As given below: metallic tape, steel tape, and inverted. Yeah. Now let's move to metallic tape. Yeah. Lengths of 2 meter, 5 meter, 10 meter, 20 meter, 30 meter, and 50 meter. Yarn interwoven with metal fibers. Metal rings to hold at the other end. 16 millimeters wide, marked in cm and millimeters. Rolled out by pulling and rolled back using rotating handle. Commonly used for ordinary survey work. Yeah. Now let's move to steel tape. Steel tapes are made of galvanized steel or stainless steel. They are a bit costly, as you can see, galvanized steel. Lengths from 1 meter to 50 meter, marked in meters, decimeters, and centimeters with end section in millimeters. Costly, but very accurate. As I said, they are a bit costly, but they provide you with accurate measurements. Can be pulled out with the handle and rolled back automatically, and they are like they are not, you cannot handle them roughly. They are a bit, you have to treat them carefully. Used for accurate survey work. Like invert tape, made of an alloy of steel and nickel. Yeah. About 6 millimeter wide in and in lengths of 30 meter, 50 meter, and 100 meters. Very low thermal coefficient, used for precise work as in baseline measurement. Yeah, should be handled very carefully. Yeah. They cannot withstand pressure. So other accessories for chaining includes ranging rods, ranging poles, arrows, offset rod, wooden pegs, leads, and weights. So now what is ranging? So I didn't write that, but you should know about the types at least. Direct ranging and indirect ranging. So I'll show you what is direct ranging. It is resorted to when the stations are intervisible, but the line is longer than the chain or tape length. So so it's like here you can see these 2 points. Imagine these 2 points A and B are 2 points we are taking, but the chain length comes, the length of the chain is up to this. So so here we can see it's like the two stations are intervisible, you can see, but the line is longer than the length of the chain. Yeah. Now procedure. In the figure above, the two stations are marked and ranging rods are placed vertically at the end station. Yeah, at the end stations A and B. So the surveyor with the ranging rod and the assistant comes in between the ends and the end ranging rod and the first ranging rod. So with the chain connected to a ranging rod, and the assistant holds the third ranging rod at the loose end of a chain vertically and moves it per as the instruction of the surveyor by the mutually agreed hand. So the surveyor instructs the assistant with the ranging rod to make it to align it with this ranging rod. Yeah. So the survey should stand about 60 centimeters behind the end survey station to which the chain is connected, in line with the ranging rod at the other end, and direct the assistant. Yeah. The assistant should hold the ranging rod vertically at arm's length. With a few trials, the third ranging rod can be placed between the end ranging rod and the first ranging rod in line with them. The surveyor finally checks the alignment of these three ranging rods. So basically, what he does, he tells the assistant with ranging to come in so to come in alignment with this ranging rod, so that all the three ranging rods are aligned. So it's a bit of like trial and error method. So you have to do it, then only you can understand it properly. Now let's come to indirect ranging. So indirect ranging is a method when the stations are far apart and not intervisible. This method, like imagine like you have two stations A and B, but they are not intervisible due to some hillocks or something. Okay. This method is also known as reciprocal ranging. The stations may not be intervisible due to intervening high ground, yeah, as I was saying, and small hillocks. Consider the stations shown in the figure below, where A and B, not below actually. So here, A and B are two stations, and A and B are not intervisible due to this hillock, small up ground. That's why they are not intervisible. So what we'll do is consider the situation shown in the figure below, where A and B are two stations with a large distance between them. A and B are not intervisible. The method is to select two intervening stations C and D such that from C both D and B are intervisible, and from D both A and C are visible. Procedure. With ranging rod placed at A and B, yeah, A and B ranging rods are placed. Two persons take up the positions with ranging rods at C and D, as closely aligned as possible. Yeah. Now, with the line joining A and B, yeah, the person holding the ranging rod at C then directs the person holding the ranging rod at D to come in line with A. So he tells the person holding the ranging rod at C, yeah, tells the person holding a rod at D to come in line with A and D. Okay, so A and B, sorry. To come in A and B. The new position of the rod at D is D1. Yeah, here you can see it is D1. Now the person with the ranging rod at D1 then directs the person holding the ranging rod at C to come in line with A and B. Come in line with A and B. So the new position of C is C1. Yeah. Similarly, again this thing happens. So there's a new position of D like D2. So for C also there's a new position like C2. So it happens. The process is repeated alternately by the persons holding the ranging rods at C and D. With a few trials, the ranging rods at C and D will be placed in line of A and B. Yes. Each person can finally check the ranging rods are placed with A and B by seeing that the two stations are visible to them in line. So they'll basically check the alignment. So you have to do it like you cannot understand by this way. You have to do it practically. Then only you can understand it properly. So thank you for having me. I guess this was helpful. But thank you.